So let's discuss some of the questions which I have provided you to for the practice. So this is first numerical, though we have done this type sort of questions many times. A sinusoidal message signal with frequency 10 to the power 3 Hz and amplitude 5 volt phase modulates a carrier signal with amplitude 10 volt and frequency 10 to the power 8 Hz. So derive the equation of phase modulated waveform. So you remember that the phase modulated waveform is AC cos 2 pi f ct plus kp mt. So you can just say that for phase modulation waveform, our phase deviation is directly proportional to your message signal. And what is your phase deviation? Instantaneous phase minus 2 pi f ct is equal to, and if kp is your proportionality constant in radian per volt, so instantaneous phase will be kp mt plus 2 pi f ct, and therefore since we know that any angle modulated waveform has a form of type this, and theta it you have already derived for the phase modulated waveform. So this is the equation of your phase modulated waveform, where kp is in radians per volt and it is a phase sensitivity of the phase modulator. So once we have this formula kp mt, you can just replace the values from here. What they have asked, the phase modulated waveform, and find the maximum phase deviation. So maximum phase deviation is nothing but if you remember first, this is just whatever I have explained here, you can understand it, that this is your message signal, this is your carrier signal, and this is your phase modulated waveform. You just replace value of kp mt and fc here. So this is the equation of your phase modulated waveform according to this description, and this is just we have drawn a simple circuitry, it looks good. Okay. So the next question is, what is the maximum phase deviation? So this is the phase deviation, which is kp mt. So maximum phase deviation means kp into max of mt, and your mt is your 5 sine 2 pi 10 to the power 3t, 5 sine to the power 10 to the power 2 pi into 10 to the power 3t. So max of mt is 5. So you can simply say that the maximum phase deviation is 5 radians. Similarly, what we can do, we can also derive what is the maximum frequency deviation of this phase modulated waveform. So for this you have to first evaluate the phase deviation, frequency deviation, which is instantaneous frequency minus carrier frequency, instantaneous frequency of the phase modulated waveform minus the carrier frequency of the carrier wave. So fit is nothing but 1 upon 2 pi d theta it by dt, and you know theta it from here. So once you evaluate, it is nothing but kp by 2 pi m dot t, or m derivative of t, and once you evaluate it and put the value of kp and everything, you derivate the mt, you get the answer as 5 kilohertz. Just do it, it's very trivial to get this. Just put mt is equal to 5 sine 2 pi 10 to the power 3t. So this completes the first numerical, which is how to derive the phase modulated waveform and what is the frequency, maximum frequency deviation, what is the maximum phase deviation of this APM waveform. Next question is, if an angle modulated signal is given as this, what is the value of modulation index? So you can simply say that if your message signal is a sinusoidal signal, so for a sinusoidal signal, any angle modulated waveform can also be written as this. Okay, this is one alternate form when your message signal is sinusoidal signal. where beta denotes the modulation index. So, if you compare this with this, C will be the modulation index. This you know, right? Now, in the if the above waveform in equation 1 is assumed to be a phase modulated waveform. See, first here we have just said that it is an angle modulated signal, but it might be PM or it might be FM. So, here they have specifically mentioned that it is a PM waveform. Then what is the value of the phase sensitivity? Given AM is equal to 2 volt. So, you have to just write first the equation of the phase modulated waveform, which is this, and put your MT as AM sin 2 pi FMT, and then compare Kp AM with C, right. So, Kp is C by AM or C by 2 radians per volt, because any phase modulated waveform has this form. You replace MT with AM sin 2 pi FMT. So, you get this, and you compare Kp AM with this. So, Kp AM is equal to C. So, you can also say that Kp is C by AM or beta by AM, right. In this question we have said that if a PCM system samples a message signal with a bandwidth, the bandwidth of this signal is in frequency domain. If we see the magnitude of its Fourier spectra, the bandwidth is FM. So, this is FM and this is minus FM, and then we quantize it with L levels. What is the bit rate at the output of this encoder? So, we have done it many times, right. So, at the output of sampler, we know that we have to sample with at least twice the bandwidth of this, then only we can reconstruct, right, using the sampling theorem. So, we say that the sample rate, if nothing is given, that what is the sampling rate, you can say that we will sample it with twice the maximum bandwidth. So, that the sampling rate or the rate at which the samples are arriving at the output of the sampler is twice FM samples per second. Then since the quantizer is using log 2 L number of bits per sample, so what would be the rate at the output of the encoder? 2 FM samples per second here, and then after the quantization and encoding, so you can also put this sign here, which says the nearest integer, nearest largest integer. Okay. So, the rate is 2 FM log 2 L bits per second. This question we have done many times, right. Here I have derived the modulation index for the phase modulated waveform and the FM waveform. This is a very I would say very good question. I mean, in terms of it will clarify all your doubts. So, any PM waveform has this type of structure, right. This is the canonical form of a PM waveform. We define our beta as the maximum frequency deviation divided by the maximum frequency of your message signal, or because it is a modulation index. So, it is only defined for the tones. So, we say what is the frequency of your message signal, which is FM, maximum frequency of your tone. So, beta is defined only, this is the note, so that you know that it is only defined for the sinusoidal type of message signals. So, once you put it here, you get your XPM like this, right. You have replaced your MT with AM sin 2 pi FMT. So, this is nothing but the instantaneous phase of your PM signal, right. Our aim is to derive beta. So, we have to first derive maximum frequency deviation, right. So, maximum frequency deviation, in order to derive the maximum frequency deviation, we have to first derive the instantaneous frequency, and then we have to subtract it with the carrier frequency, because you know that our delta F is nothing but instantaneous frequency of your PM signal or AM signal, or combinedly you can call it angle modulated signal minus the FC. So, in order to derive this, we first derivate our instantaneous phase and divide it by 2 pi, and then we just maximum frequency deviation will be this, it's a simple step from here to here. So beta is kPa. Similarly, for FM signal, you can derive the modulation index using this formula, which is maximum frequency deviation divided by FM. So for this, either you can use the formula, which is, you know, that for FM signal, FIT is nothing but SC plus KF MT. So delta F is nothing but KF MT. So maximum frequency deviation is KF into max of MT, and since your MT is a sinusoidal signal, so KF, it's a quite trivial. Thank you.